Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to our Pixel Platformer series in Godot. This is part 13. This series was made possible by the people who support my channel by purchasing my 1-Bit Godot course. There will be a link in the pinned comment and one in the description if that's something you're interested in. Let's get started. In the last video, we implemented our, we set up our game with a spawn point and then allowed for checkpoints like that. Now, actually, I just noticed if we jump into the ladder and hold up, we'll immediately start climbing the ladder. It feels a little weird. So before we get into the video, I'm going to change that. This is a design decision, not necessarily a programming one. But we can make it so that inside of our move state, in order to transition to the ladder, it should be is action just pressed. That's how I'd prefer it anyways. So if I'm holding the up button and I'm not in the ladder, it just does the jump. But if I press it again while I'm touching the ladder, then it will transition to climb. And that feels better to me personally. Okay, so what I want to do in this video is I want to add the Thwomp style enemy. Now I call it Thwomp, that's from Mario, but it's, if we look at our character pack here, no? Yeah, it's in our character pack here. This yellow one, it's just kind of a brick enemy that we can have maybe be up high and then like come down and try and smash the player. That's kind of what I was thinking. So we'd likely use a state machine, a simple state machine, kind of like our player. And we'd probably use what I'm thinking is we'd make it, we'd make it use its start location as the location that it returns to, and then it would just fall until it hit ground, and then slowly raise back up to its start position again. So there'd be two states, a falling state where it comes down to try and hit the ground, and then one where it raises back up again. And we could have it just automatically play that, or we could have it try and detect if the player is nearby. I think we'll start with automatically. So let's create a new scene. And I'm thinking for this scene, we'll use our hitbox on it. So if the player touches it, the player will die. The other design option would be to make it so that the player can actually stand on it by making it like another kinematic body or a static body or something like that. Then we'd have to be able to detect if the player is getting squished by it. And I don't want to go into that. So I'm just going to make it so if the player touches it, the player dies. I think that's how it is in Mario. We'll do a 2D scene and we'll just call it Stomp Enemy maybe. And we'll attach a sprite, an animated sprite. We'll do frames. We'll grab our... Did our tiles have like a better enemy for this? I didn't think the tiles had enemies. Yeah, it doesn't look like it does. Okay, that's what I thought. So we'll have a falling, we'll have a rising animation, and this will just be, let's see, what are we, 9 by 3. This will just be this kind of normal one. And then we'll have a falling animation. And this will be the angry face. There we go. We've got rising and falling. We'll have our default be rising. And we will attach a hitbox. Ooh. We got to do a scene hitbox to this one, and to that hitbox we'll attach a collision shape, and we'll just make it a square, And we'll come inside the corners here to give the player that little bit of leeway. Now, we need it to be able to detect the ground, so it's going to need a raycast, right? Since we're not using a kinematic body for this, it's going to need to raycast down to detect whether or not it's going to hit the ground, and then update its position so that it's right on the ground right when it lands, because we'll probably want to have a pause, right? It'll hit the ground, pause. Yeah, that's what I'm thinking. So we'll do a raycast. And I actually want to move up the sprite. Oops. I'm going to move up the sprite and the hitbox actually. So I'm going to hold control, select them both, and then use the arrow keys to move them up. We'll come right to here. And then we'll move up the raycast too, actually. And we'll turn it on. We'll have it collide with the world and bodies. That makes sense. Definitely want a shorter length though. 9, I think, is what we want for the length. That just means it's right going to be touching the ground. In fact, we might do 10. So it's 1 pixel lower. We'll try that. We'll have to see how this works. What I'm thinking is when we raycast and we collide with the ground, then we can detect where the collision happened and move to that point to make sure that we're never the enemy never goes inside the ground, but kind of snaps right to the edge. That's what I'm thinking. Let's actually save this now. Stomp enemy, and we'll attach a script to it. And we're going to do our enum up here at the top for our states, and we'll do rising. Let's see. We'll do hover, fall, rise, hover, fall, land, rise. We'll have a land state where it stays there for just a few frames. Although we might be able to do that at the end of our fall. We'll see how this works. Okay. We're going to set up our state variable. We'll set it equal to hover for now. We're also going to need a variable for our start position, the very first position we are in the room. We can set an onReady variable for this. Start position, and we'll just set it equal to position. Or global position, just in case we're attached to another node that's got an offset. onReady, I forgot the var. And we'll have our physics process. And inside of here, we'll match our state. Hover, pass. Fall, pass. Land, pass. Rise, pass. And let's make some functions for each of our states. The hover state's not going to do much, right? It's just gonna sit there for maybe duration. So these functions are going to be called every single frame, every single physics frame. And so setting a duration on them, we could you can't start a timer in them. That's what I'm trying to say. Otherwise it'll start the timer over every single time. Although you could check to see if the timer was 0 and then set the timer. So if the time left is 0, then you set the timer. We could try that and see if it works. I haven't done that before. So it'd be interesting to see if this is a possibility. We'll make it one shot, but we don't want it to auto start. We'll set the wait time to 0 by default. Oh, you can't do 0. We'll just leave it. we wanted to process an idle, that's fine. And then we'll say, up here at the start, we'll say onReady var timer. We'll get our timer. And inside of our hover function, hover state, inside of our hover state, we'll say if timer.timeLeft is equal to 0, timer.start. Yeah, see, the problem is we need to be able to get the timer. For a second, I thought I would be able to do this. Get the timer, set it to 0, or set it to start, and then once it reaches 0, we transition to a different state. But you see that the trigger for setting the timer and the trigger for transitioning to the different state are the same. And so that actually doesn't work very well for a situation. Now you can have, this is where a more complicated state might be beneficial, because you can have states that do things right when they start. So right when the state is initially set. And we could do this with a setter. And it feels like a little bit of overkill for our current situation, though, if I'm being honest. So let's start with just the basics. Let's get something working. So our hover state is going to, let's make our hover state immediately transition to the false state. So state equals fall. We got to get something on the board. That's what we got to do here. Now we'll make our fall state. Now in this state, we need to get access to our raycast. So onReady var raycast equals raycast2d, and we can move down. So we'll say position dot y plus equals, and this is going to be our fall speed, and we'll set this to, this won't be using delta, so let's do something like 10. And then we can say if raycast 2d dot, oh no, not raycast 2d. We want to get access to our normal raycast here. I was thinking about something else. If raycast dot is colliding, var collision point equals raycast dot there's a way to get the collision, the position of the collision, I think. But we might have to get the collision first. Collision. So var collision equals raycast dot get. Oh, here we go. Get collision point. That's what we were looking for. So we can just grab the collision point right away. And then we can say position dot y equals collision point dot y. So we'll set our y position to be the exact collision point. Now the reason this will work is because you can see our sprite and our hitbox are offset in a way that makes them sitting right here on the origin. So our origin is right here. So when we set our point, when we set our enemy's position to the collision point, it will be exactly on the ground where it collided. That's the idea anyways. That's what I'm going for. And then we can transition state equals land state. Okay. So now we got to make sure and call these states. So inside of hover, we'll call hover state. Inside of fall, we'll call fall state. And inside of land state, we'll just call pass for now and just see how things go. I think we should try this. So our script is attached here. Our state is set to hover at first, which transitions right to the fall state, which then should move the enemy down and get a collision. And if it does collide, then it should switch to the land state and just stay there. So let's see how this looks. Stomp enemy. And we'll just stick it right here for now, I guess. Okay, so good landing. And our player can die from touching it. So that turned out surprisingly well. Unfortunately, our state acts so fast that we can't really see what's going on. Let's make it move down slower. We'll just do 2 pixels per frame. And there we go. See, this is what happens when it's not being affected by delta. Even though the delta value in the physics frame is consistent 60 frames per second and doesn't have a variable delta, it's still just so fast not to multiply it by delta. So we could multiply this by delta if we wanted to. We could pass delta into our fall state. And then multiply this by delta. Like this. So we put delta, we pass it in here, and make sure our fall state can accept a delta value, and then we multiply our movement by delta. And now we're moving way slow because we've updated it. It's getting multiplied by delta. So again, I want to reiterate that delta is not, you can multiply everything by delta, and if you are using the process function, you need to be doing that. In physics, technically it's locked at 60 frames per second, so you don't have to be doing it. But it could be wise to do it in order to have your values, your speed values consistent across your game, like in this particular section. Or for example, in our player, how our movement data for our player doesn't make a lot of sense because move and slide multiplies the velocity by delta automatically, and our acceleration stuff isn't using delta. So then our acceleration values and our movement speeds look very different from each other. You know, like our acceleration is 15 and then our max speed is 100, and that doesn't make a lot of sense except if you apply delta 1 to one and not the other. Okay, now we have our land state. Let's have our land state transition directly into our rise state. So state equals rise. We'll make a rise state function, rise state. And with this state, what we're going to do is we're going to use move towards to move back towards our start position. So we'll say position dot y equals move toward from, that's going to be position dot y, to, we want to move back to our start position dot y, and delta is, it says delta, but that's not this delta. This is a different delta. This is how much we want to move each time. And so we could use this same value up here. That would be very fast. Let's pass delta into our rise state though. So we'll have land state, and we'll have with parentheses, and then we'll have rise state, and we'll pass in delta here and here, delta, and then we'll say we want it to rise much more slowly, so 10 times delta. That should move us back up again. So it hits the ground and then slowly, very slowly, moves back up to its start position and then stops. Now we can say we need to transition back to the falling, or back to the hover state. So we'll say if position dot y is equal to start position dot y, then we can say state equals hover. And that will transition back to our hover state. So now we've gone full circle. Hover state switches to fall, fall switches to land, land switches to rise, and rise switches back to hover, and we've created a full loop now for our enemy, where it falls down, slowly climbs back up, and then immediately falls back down again. Now, we have set this up to where it immediately switches out of the land state, which feels really awkward, right? That feels super awkward because it feels like it barely touches the ground. It doesn't like slam into it hard. So how do we make it so that we can wait here? Wait inside of our land state for a bit. Now, we were talking about using timers, and there is one way we can do this, which is we can set the timer right here when we transition states. So we could say timer.start, and then we could set it for 0.75. No, let's do a whole second, 1.0. So we can start the timer in here, and then inside of our land state, we could say if timer dot time left is equal to 0, then switch back to the rise state. Now, why does this work? Why can't we do this? Why can't we put this in here like this? This might be your first thought, right? I'll do Control K to comment this out. Your first thought might be, well, why can't we do this? Well, the problem with this is that this land state gets called every single physics frame, which means it would start the timer at 1, it would check to see if the timer was 0, and it wouldn't be because it's at 1. And then, so then it would exit out, and then the physics process would run again, and it would start the timer at 1 and check to see if the timer was 0, and it wouldn't be again because we're setting the timer to 1 every single frame right before we check it. So why does this work? Well, this works because this timer only gets set when the raycast collides in the previous state. So it gets set right here in the previous state when the raycast collides, and then we transition to the land state and it never gets set to 1 again, unless we come all the way back around to the fall state. So this allows us to properly set the timer. And this is the easiest way to do this, in my opinion. There we go. Man, rising is too slow. Let's double it. There we go. Now we need to take advantage of our angry face. I'm very disappointed that I totally forgot about the angry face. So on ready var animated sprite equals animated sprite, and we can say inside of our fall state, not that, animated sprite dot play falling. Is that what we set it to? Let's check. Man, I hate having to use strings. Okay. And then inside of our rise state, animated sprite dot play rising. There we go. So boom, angry, and then we raise back normal. It's adorable. These were great little graphics that Kenny did. And if we wait under there, we're gonna get squished. It's gonna squish us. That looks pretty good. Okay, so one of you actually was saying in the comments that One of you was saying in the comments that learning particles could be important. And you know what? We're only about 25 minutes into this video, so I think we've got a few minutes to put in some particles. So we're going to attach a new node to our stomp enemy. Let's save first. We'll do a new node, we'll do a particle. Now you have CPU-based particles, which are run on the CPU, and GPU-based particles. And they have some slightly different properties as far as I know. Other than the fact that it's what it says right here, that one runs on the CPU and one runs on the GPU, I'm not entirely sure what the difference is and when you should use which one. So if anybody knows the answer to that, please leave a comment below and I will heart it so that other people can see. But to me, it sounds better to use GPU-based particles, at least if you're exporting to PC. So that's what we're going to do. We're going to use CPU-based or GPU-based particles, which is the particle 2D. And you can see when we add that node, we immediately get a little white pixel here that's doing nothing. That's actually our particle. And if we come into these properties over here, we've got a lot of properties. We've got time, drawing, process material, textures. So the first thing we want to do is set the lifetime, and we're going to set our particle to be full explosiveness. The explosiveness just determines how quickly the particles are emitted. We've got it set to 8 particles. Let's do something like 32 for now. To give your particle a lot of information, I guess, or properties, you need to create a process material. So we're going to click here and do new particles material. And now we have a white drop that drips for a second. Okay, and if we come into here, we've got a whole bunch of new properties for this particle. And we're not going to cover every single one here. We're just going to try and make some dust clouds that we can have poof up when the stomp enemy hits the ground. So the first thing we want to do, our particle is only emitting from this point. So if we come up into, our emission shape right here under our particles material, we can set it to be a box. And then we can set the box extents, which is basically, it's kind of like a radius for a box. And you can see this one's set up in 3D. I don't know why we have 3D here. We could set Z to 0, I think. Don't need that. So this is 1 high in the Y. And we might be able to do a little bit bigger than that, maybe 4. 4 feels too big. Let's do 2. Okay, you can see it's emitting from 2 pixels up and 2 pixels down. So that's why I say it's like a radius. Even though the Y is 2, our box is 4 pixels high. It's 2 up and 2 down. Now we know that this is 18 pixels, so we'll do 9 in the Y, and that should get us emitting exactly at the base of our enemy here, of this square. So we've set up an emission shape now. We can click on this to get rid of that. And our particle has a gravity right now. And we might want it to have a gravity, but definitely not this strong. So we're going to set this to, let's do 9.8. And now our particles fall much more slowly. Now we have a direction. Currently the direction is set to, well, before we set direction, we need to set our initial velocity, otherwise it won't matter. So let's set an initial velocity of 10. And you can see our particles launch to the right now because we have a velocity of 10. And let's give them a velocity random of 0.5 maybe. And that will add some randomness to their velocity. And my guess is that the numbers work out to be, we now have a random range between 0.5 and 10. That's my guess. If we were to set this to 1, we'd have a random range of 0 and 10. In fact, 1 looks a little better if I'm being honest. Okay. So we've set our initial velocity. Now we need to set our direction. We don't want them to go to the right. Well, actually, we're okay. Yeah, we don't want them to go to the right. We want them to go up. So we'll do -1. So now the particles launch up when they're created. You can see them popping up like that. And they have a spread of 45, which means if we do 0, then they're going to launch straight up every time. And 45 gives them a 45-degree spread. So they'll kind of launch out at different angles, which is what we want for this situation. You can see our gravity still feels too strong since we're going for dust particles. So we might do 2 for our gravity. So they do slow down a little bit. Now, our particles, if we come back to time, clear up here at the top, it feels like they're not lasting quite long enough, in my opinion, for a dust particle. But I don't know. Let's leave it for now. So let's minimize direction, minimize gravity to try and stay organized. It can be easy to get lost in this. So we're going to go to our scale here. And the scale is 1 and there is no randomness. And we definitely want to use some bigger scale for this. So let's go to, not that big. Let's go 2 and then add some scale randomness of 0.5. That looks like the scale randomness isn't working at all to me. Huh. I can see if I max out the scale randomness that there are different scales now. But it still feels pretty close to the same thing to me. We'll leave it at that for now. Let's come into our color. For our dust particles, we're going to want kind of a gray color. Like this. But we'll probably want them to be kind of transparent too. So we'll set the alpha to 100 maybe. Maybe 150. 100 was pretty... Now we could set their angle. I don't know if that will affect... it does affect them. So we can give them an angle of like 360 and then add randomness so that they're not all just perfectly square. Now this can get into whether or not you want your game to be like everything exactly pixelized. And if you want to do that, you can use a texture for your particles. So you could have a specific texture, but we're just going to use the default pixel here. Now for our color, we can set a color ramp, and actually that's what we're going to want to do. I forgot about this. So come to color ramp, click new gradient texture, and then you click on that, and wait a minute. New gradient. Okay, so we do new gradient texture, then new gradient. Now you can see if we click on gradient, we get this menu right here. And you should have a color here, and a color here in your menu as you come down into each resource. We have color ramp, gradient. So our first color, if we click over here, we want it to be a gray color, and we want it to be transparent. Like 150. Now if you click this little plus button, it will add our gray color as a, it's hard to see. If we were to do a new one, it would add it like that, but we want this one. It will add your color down here so you can select it. Now we're going to come over here to the right side and click over here. You can see we can drag these around. So keep that in mind. We're going to click on this. Double click maybe. click on this, click over on this square, and this will bring up our white. We can select our same gray, only we can drag the alpha all the way down. Now you can see our particles, I had to click on this again because it went away, fade away. That's what we're creating here is a fade. Now our first color doesn't look very good. I'm going to click on it. We'll select this lighter color and we'll make it 170 or something. I think we should use the lighter color for both ends. So I'm going to use the lighter color for both ends. Oh, but I forgot to bring the alpha down on the second one. It's a little hard to see because the alpha value is low on both of these. Now we could click again anywhere in here and it would give us a third value. So we could have the colors fade out only at the very end if we wanted to by having 1, 2, 3 color values in our gradient. So you can add multiple values to your gradient to get a transition from one color to the next across time. This is going to probably be it for now, for this. Let's see how it looks in our game. The first thing we want to do is scroll up and turn off emitting. So our particle will no longer emit. Then we're going to come into our code and we're going to get access to it. On ready var particles. And we can make it so that when we transition to the land state, so that's going to be where we set our timer too here, we'll say particles dot emitting equals true. So we'll turn them on. So what's this going to look like? Well, when we run the game, it's going to land and emit the particles, but the particles keep emitting, right? When we land. Now, we could make it so that the rise state turns off the particles. Particles dot emitting. And you don't have to follow along because we're probably not going to keep this. Particles dot emitting equals false, like this. Boom. And this works. I think this works just fine, honestly. But the other option is to, I'll just comment that out. The other option is to turn on, in your time, turn on one shot. And that just makes it so that it only fires the particles once right after you turn on emitting. And you can see that it just does that. So either one of these is fine. Probably one shot is the more common way to do it, maybe. But it seems like either one works fine in our testing. I still don't really like the way our particles look. So I'm going to come back into our scale here. And, well, this is the value of using turning off emitting, is that if you have one shot on, then it also only does it once in the editor, which can make it harder when you're trying to see what your particles look like. So I guess that's the value of doing it the other way. Let's set our scale here to 4. And let's come back into our color. And I actually think I'm going to right click on this one to get rid of it. If you have multiple, you can right click on them. And I'm going to set our color just be equal to white. And then just have an alpha value for both of them. So they're white and they'll start off with an alpha value. Which one am I on? Oh, I'm lowering the alpha. Huh. Even just starting them completely white, it doesn't look too bad. That surprises me. But that's fine. That's what I'm doing. Both of them are set to white and then just have different values for alpha. It still says it's gray, even though we changed it to white. Oh, because I have a color set. Oh my gosh. And that's why our alpha values were so low. It's combining the two, the color and the gradient. Huh, interesting. This makes more sense now. Okay, so I'm gonna get rid of the color, so the color is just white now. And then inside of our gradient, we can change this to have an alpha value. And that makes everything make so much more sense. The values were a little weird to me, and I couldn't figure out why. That's on me for not understanding exactly how that worked. Now these particles don't feel very explosive, and we have explosiveness set to the max. So what that means is our initial velocity isn't high enough. We might consider a 20. And now it's constantly emitting again, which of course ruins the effect. It really is kind of nice to do it this way. I've never done it this way before. I've always used one shot, but it's kind of nice to do it this way because then when you're editing the particle in the editor, you can see it constantly. But then in game, it just does this. Okay, looking pretty good. Let's set this to be higher. Little bit more impact. Boom. Oh, that's funny. Well, it looks pretty good. I like it. Maybe you want your dust to be brown to try and match the dirt or something. But I'm pretty happy with how this turned out with our little guy. Oh, see, there's the problem with setting emitting to false. We actually had it emit twice. See that? So yeah, it doesn't work. It doesn't work. But what we can do, I just realized, is in our ready function, we'll create a ready function. We'll just say particles dot one shot equals true. So that way in the editor, we can see the particles applying constantly, but in the game, one shot will be equal to true. And it is starting off with the particles running because it's emitting in the editor, which is really interesting to me that works. You'll notice right when we run the game that the particles are emitting, and it's because they were emitting in the editor. I don't know. We'll turn off emitting, and one shot will be equal to true. And this works perfectly now. That is a little finicky though, all the worrying about whether emitting is on or off and stuff like that. It's kind of a little bit weird to use. But there we go. Now the other thing is, currently our particles end at exactly 1 second, but let's say you wanted them to last for 2 seconds. I want to address something here that may come up in the comments real quick. If we run this and the particles last, you can see they rise with our character. Now, the way you can change that is if you come into the particles and you come into their drawing, you can see there's a checkbox here called local coordinates, which means they will use the coordinates local to the stomp enemy. If we uncheck this, then even if our particles last longer than the enemy, they don't follow the enemy anymore on the way up. And that actually looks pretty good to do it that way. So there we go. There's our particles. The basics for using some particles inside of a game. Hopefully you found this helpful. We're 45 minutes into this video, so we went pretty long with it, but I think it was a fun one, adding a whole new enemy, learning some about particles. That was kind of a bonus at the end. Hopefully you all learned something and enjoyed it. Thank you so much for watching, and I will see you all in the next one.